There's some massive AI news on the horizon, and it's quite shocking. First on the scene is Figure 01, the OpenAI-backed robot that is advancing quite rapidly. Here's Brett Adcock, the founder of Figure 01, of Figure AI, the company. He's saying robots plus AI are the next great frontier. We demoed some of the latest AI on our robot during 60 Minutes last week. I'm not sure if 60 Minutes is a Twitter account or what, but seems big. Figure 01 is connected to a pertained, I'm guessing that's pre-trained model via OpenAI to output common sense reasoning. So when Bill says, hand me something healthy, the robot, by visual reasoning via robot cameras, knows this is the orange in the scene and not the chips. The behavior of this robot grappling the orange was an in-house trained neural network. The models is mapping camera pixels at 10 hertz to robot actions. Speaking of robots, you know how we tend to kick them for demonstrations? We gotta stop doing that. Now it's even worse. We're kicking whatever they're standing on from underneath them. We're trying to, at least. We're doing that. We're recording the evidence. We're taking the footage. We're putting that footage on the internet. And then we train the AI brains on the internet. Is no one else concerned about this? No, just me? All right, fine. So Dr. Jim Fan is saying we trained a robot dog to balance and walk on top of a yoga ball purely in simulation, and then transfer zero shot to the real world. No fine tuning, just works. And we've been talking about this on this channel for quite a bit. This idea of training robots in simulation, having them figure out the skills to walk, to move, to balance, to open doors, to pick up and transfer packages around. Something like NVIDIA's Isaac Gym can run these simulated worlds where the physics exists just like they would in our world, but they're able to run it at 10,000 times the speed, like Dragon Ball Z. And he continues, I'm excited to announce DrEureka, an LLM agent that writes code to train robot skills in simulation and writes more code to bridge the difficult simulation reality gap. It fully automates the pipeline from new skill learning to real-world deployment. If you recall, when we covered the original Eureka paper on this channel, you realize how fast this is moving. The yoga ball task is particularly hard because it's not possible to accurately simulate the bouncy ball surface. Yet, DrEureka has no trouble searching over a vast space of sim to real configurations and enables the dog to steer the ball on various terrains, even walking sideways. Traditionally, the sim-to-real transfer is achieved by domain randomization, a tedious process that requires expert human roboticists to stare at every parameter and adjust by hand. That was the big breakthrough that we saw in Eureka. Instead of tedious work done by humans, we just quote-unquote outsource it to GPT-4. What do you think happens when we have GPT-5 in the scene? Might this process get better? Maybe. Dr. Jim Fan continues, frontier LLMs like GPT-4 have tons of built-in physical intuition for friction, damping, stiffness, gravity, etc. We are mildly surprised to find that DrEureka can tune these parameters competently and explain its reasoning well. DrEureka builds on our prior work, Eureka, the algorithm that teaches a 5-finger robot hand to do pen spinning. It takes one step further on our quest to automate the entire robot learning pipeline by an AI agent system. One model that outputs strings will supervise another model that outputs torque control. All right, so here's Eureka. This was the original one, right? So this is not what he's talking about. This is the predecessor. Let's see when this was published because it wasn't that long ago. So looks like revised April 30th. Looks like originally appeared October 2023. And Eureka did something really cool. It taught a robot hand, this shadow hand inside a simulation, right inside of something like NVIDIA's Isaac Gym, to spin a pen or a pencil, you know how kids do in school sometimes, in various different right directions, upside down, right side up, etc. Different configuration of fingers, etc., which has never been done before. It was a very complex problem. But how they did it was perhaps even more interesting because what they did is they set up this architecture where, so this is GPT-4, right? So large language model, in this case, GPT-4. Keep this in mind. This section is, this area is improving constantly. So this was at the end of last year, this is how good it was. Where is this going to be a year from now, 5 years from now, right? So we have the environment code and the task descriptions. The environment code is the Isaac Gem. So we're writing reward functions for these robots. We're basically saying when it does something right, we give it an attaboy. Or if it's doing something wrong, we write in a penalty. We're trying to teach it how to do things with positive and negative reinforcements. It's the environment code. We feed it into GPT-4, and GPT-4 produces sampling on the various reward functions that it could run. So it just produces a bunch of them, right? And they're getting tested. They're put into the GPU, accelerated reinforcement learning, so the simulation, if you will, right? And these shadow hands, right, sit there in the simulation and spin these things at, 10,000 times the speed of the flow of time in our universe, if you will, right? And then we get the results back, and we put those results back. We provide it to GPT-4, and they're like, well, here's how well your code did, right? And it's saying, please carefully analyze the policy feedback and provide a new, improved reward function, right? So it does it, we test it, we give it back to it, and we say, here's your results, do better. And it does it again, and we're like, do better. And it does it again, and we're like, do better. And it figures out how to train these robots better and better. Over the different iterations, it keeps improving. So these are the Eureka iterations, right? So you see as it goes from 1, 2, 3, 4, 5, the success rate, right? It keeps improving. But there's one last thing that's going to blow your mind, and that is this. Eureka generates novel rewards. So I encourage everybody to read this paper because I'm not going to do it justice by explaining it simply. If you want to dive deep into it, I strongly suggest you read it. But basically, it seems like for simple tasks, both the AI trained model and the human results, right? They're similar. Both the AI and the humans, we write similar types of code for these reward models. But where it gets interesting is as those tasks get more and more complicated, right? So for example, with pen spinning, or this thing where it has that Rubik's Cube or whatever, and it's like rotating it, or these little helicopters, quadcopters, whatever you want to call them. So for those more complex tasks, the harder the task is, the less correlated the Eureka rewards. And the rewards that it writes, they're novel. So that means as the tasks get harder, humans have a hard time coming up with the good solutions. The AI comes up with different solutions than the humans would come up with. And those solutions are better for those advanced tasks. If you're getting what I'm saying, it's probably kind of blowing your mind. But getting back to this new thing that just came out, DrEureka, so it's language model guided sim to real transfer. Now we're beginning to take the learnings of those robots in simulation and we're applying it to the real world. And we're getting this dog that's able to balance on top of a ball. And as far as I can tell, I don't think these are cherry-picked results. I'm sure it fell off once or twice during testing. But I gotta say, number one, certainly it's better than any human can balance on something like that. But I almost feel like we're getting to the point where maybe it's better than any animal. It's either already better than any animal that size could balance on it. Without using its claws to dig in. Notice it's pretty smooth. The legs are smooth, right? So maybe it's got some rubber padding on there for friction, but it's not really gripping the ball. It's specifically, take a look at this one right here on the right in the center, what it does when it starts slipping off of the ball. There it goes. So it's kind of like getting faster and faster, almost overcorrects, still catches itself and still gets to kind of the center. It's insane. Anyway, so this is the DrEureka component. So it's probably very similar to the original Eureka. I haven't read the paper yet, but I am planning to. We might have to do a deep dive because this is absolutely out of this world. But as far as I can tell, so we're taking this simulation, right? Similar to what we did with Eureka. In fact, this is the Eureka reward design initial policy learning. So that's what we covered previously in the Eureka, right? And that reward function that GPT-4 or whatever comes up with, that gets fed into this final sim to real policy learning, right? So it learns those things in the simulation. And then that code, that neural nets, that sort of data gets loaded into real world deployment. And here they have kind of the uncut deployment video. So we'll just take a look at this for just a little bit. So here, it's looking very good, and they have more of a long shot of this thing moving around. I'll post it below if you want to take a look at it, but I kind of fast forwarded through this thing. As far as I can tell, it never falls off. It stays on that ball walking for 5 minutes straight, doesn't mess up, doesn't fall off. And here's one where they're actually deflating the ball as it goes. I mean, the sound is on just because you can hear the thing deflating. So it's rapidly deflating as the thing is balancing. And here I'll skip forward just a little bit. So it's like maybe 80% deflated, and it's still managing to stay on top of it, even though it's a completely kind of different environment. And it looks like finally it kind of falls off. And I think that has something to do with the domain randomization. So basically, if you saw those DeepMind soccer robots, basically one of the things they were talking about there is they randomize a lot of the little things that go into that simulation, that world, right? So they'll slightly randomize the friction coefficient. They'll slightly randomize, how much electrical current is going to the robot's left leg versus its right leg, right? So just like in the real world, not everything is perfect. So we can't simulate it as being perfect. So we throw these random minor tweaks in there of various physics that the robots have to deal with. And what they're saying is that tends to make the robots very robust when they emerge in the real world. They're able to deal with, as you saw there, with the thing deflating, it's able to adapt. Anyways, we have to come back and do the whole thing. But I got to say, at one point, these things are going to get too fast, too good, and they might want to have a chat with us about all the stuff that we've put them through. So I just want to say, for the record, I, Wes Roth, I am against this practice. This is bad. I do not stand for this. I am and always have been on the robot side. For the record, don't kill me. Next up, we have more OpenAI drama. OpenAI is nothing without its drama. 2 senior OpenAI executives leave the company. 2 senior OpenAI executives, Vice President of People Diane Yoon and Chris Clark, Head of Nonprofit and Strategic Initiatives, left the company earlier this week, a company spokesperson said. And yeah, it's strange to hear this because, both executives were among the most long-tenured managers at the developer of ChatGPT at OpenAI, right? Recently worth $86 billion in an employee share sale. So, if you've been with the company from the beginning, it grew to be worth $86 billion. What would make you leave? So that's according to the information. I'm not going to read the article because, it's their scoop. It's the work that they did. So I want to be respectful of that. I'll link it down below. The information is subscription-based. But if you're into AI, I got to say, and I'm not being paid to say this, but that's the only subscription to like a publication that I have, I think. Yeah, like if you think about news publications, I'm certain this is the only subscription that I have right now. Ethan Malik posts a paper about how to deal with copyright issues for AI art. And this is interesting. Somebody has a plain English rewrite of that paper. We're probably going to see more of this. So it has kind of an overview, plain English explanation, technical explanation, critical analysis, conclusion. So I'm not going to read the AI generated stuff because, well, it could be really good. It could be really accurate, but you really got to make sure you do it correctly because it's very easy to get nonsense. But this is the abstract from the actual paper. So this isn't AI generated. This is the actual abstract from the actual paper. So it's saying, in general, AI systems are trained on large data. There's a growing concern that this may infringe on copyright interests, right? So if Midjourney is training on artists' images, right, those artists now have a competing AI model and they're not getting paid for it. And there's been a whole debate about whether that's correct or not, right? So the people that are saying this is copyright infringement, of course, are saying, well, you can't train the model on that data. Whereas the people kind of arguing against it are saying, copyright protections were always about reproducing something, not reading it, right? So like George R.R. Martin, the writer of Game of Thrones, was a big fan of Tolkien. He even borrowed the whole R.R., like J.R.R. Tolkien. We know he read the works and he created something similar, but we're not saying it's copyright infringement, even though we know he read Tolkien's works. So the reading is an infringement, but if he produced something very similar, that would be infringement. And so I think the big question is how we're going to treat AI models, right? Does an AI model reading something, is that copyright infringement? Because we haven't really applied that criteria before. So it's an interesting legal situation that will be unfolding. And basically here they're proposing a framework that compensates copyright owners proportionally to the contribution to the creation of AI-generated content. The metric for contributions is quantitatively determined by leveraging the probabilistic nature of modern generative AI models from cooperative game theory and economics. So it sounds like basically if, let's say, you're an artist and your artwork comprises 1% of the data that the model is trained on, and then they find that that model tends to use that data, that portion of the data or whatever, there's a certain probability of relying on that to produce artwork, then maybe there's a formula. I haven't read this paper, and maybe something like this will be adopted. In fact, this is what people are talking about. But again, this presupposes that reading something or looking at something by these AI systems is breaking copyright. Now, of course, if you've ever had a website, you know how many crawl bots hit your website. You have Google and Bing, and nowadays a lot of OpenAI and just tons of other stuff, right? So they're constantly crawling your site, right? We're not saying that's copyright infringement, but if they copy and paste it to their own site, word for word, then it becomes copyright infringement, right? If I make a photocopy of a book, that's not copyright infringement. If I start selling those copies, then that is copyright infringement. So again, I'm not arguing one way or another, but we got to get some clarity on, is reading something, is training on something, is that in itself copyright infringement, or is copyright infringement strictly the act of reproducing something that's similar? And this is Elvis Omar Sar. So we've looked at a few of his, he covers various papers in AI, and I think he just recently launched a YouTube channel. So Elvis Saravia, so a really good person to follow, really enjoy his stuff. So he breaks this paper down. I'll link everything down below if you want to follow him. But basically, my understanding is that the paper is about predicting multiple tokens that comes next. So tokens are the smallest unit that these large language models like ChatGPT, GPT-4, that they deal with, right? And usually it's a word, right? The is one token, sky is one token, is one token. But sometimes bigger words are multiple tokens, or if you have a misspelling, that could be multiple tokens. So if I recall correctly, like a million tokens will be 750,000 English words on average. So that's kind of the rough breakdown. And that can vary, of course, but how these large language models work, right? So we say the sky is, right? And it uses the neural networks to kind of figure out, okay, like what's the most likely word that comes next? Is it the? No, usually no. Blue, is out of all the choices is the most likely one. The sky is blue. And that's kind of the underlying mechanism for a lot of this. It's prediction. When they say inference, it means prediction, sort of the output of these models. But this paper is asking, what would happen is if instead of one token prediction, so the sky is blue, one token, what if we asked it to predict multiple tokens? And this could be kind of a big deal because, as Elvis says, the most exciting paper of the week was that one from Glockley et al. That aims to train better and faster LLM via multi-token prediction. It's an impressive research paper, but it sounds like in this work, this is the paper that we're talking about, better and faster large language models via multi-token prediction, or I guess multi-token prediction is the right emphasis there. In this work, we suggest that training language models to predict multiple future tokens at once results in higher sample efficiency. Gains are especially, so they're saying it works well. That's the point of this paper. They're saying these gains in effectiveness and efficiency are especially pronounced on generative benchmarks like coding. Coding is kind of a big deal as far as LLMs are concerned. And they're saying where our models consistently outperform strong baselines by several percentage points, right? The smaller 13 billion parameter model solves 12% more problems on one benchmark, 17% more on another. Experience on these like smaller tasks demonstrate that this new approach, the multi-token approach, is favorable, so it works better for the development of algorithmic reasoning capabilities. And as an extra benefit, these models are up to 3x faster at inference, even with large batch sizes. So meaning the outputs are 3 times faster, even when we're working with large amounts of data, with large amounts of output. There's a speech by Andrej Karpathy. He used to work on Tesla's autonomous driving. Then he went to OpenAI, and recently he left OpenAI, or not recently, I think it was last year, and started his own YouTube channel. Also another great resource for understanding how these large language models work. he in the past worked closely with Dr. Jim Fan, and his main kind of area of work is AI agents. But he was saying how when he was working for OpenAI, they have their internal Slack channel with their own messaging. And I guess they post papers like this as they're coming out. And I think he was saying that, on an internal Slack channel, they'll say things like, yeah, no, we tried that. That's never going to work. That's a dead end. Or they'll be like, oh yeah, they're onto something here. So in other words, it sounds like, for us, we see something like this and, time will tell. We'll see how big of an impact this will make on large language models. Maybe it'll be huge and it'll drastically improve how good they are, how fast they are, how easy it is to build them. Or maybe it'll be a dead end, but there's this Slack channel at OpenAI where they're kind of like, they just know ahead of time since they are kind of more advanced than a lot of the stuff that we're seeing, which kind of interesting to think about, I think. Next, we have the release of DEVIN 2.0. Now, I don't have access to this. And, as we've talked about on this channel, a lot of people think, oh, DEVIN has been debunked or whatever. I have my doubts. I really have my doubts that it's vaporware or anything like that. As more and more people are getting their hands on it, I mean, the results seem to be good, right? Now, it's important to understand that, right, there's some people that are kind of on this spectrum and they're saying like, DEVIN, these AI agents, they're nothing, right? They're completely useless and there's no applications and it's just all fake, right? And there's people kind of on this side, they're like, that's it. This is the end of, this will put 100% of software developers out of business, out of work, et cetera, right? And the reality is, I mean, neither one of those stances is correct. I mean, if there's one thing we know is the hyperbolic stuff is probably not correct. I think DEVIN and these various AI agents, I mean, they're probably like somewhere here, right? And then as they improve, they'll probably move like somewhere here, right? Maybe over time, they'll get to 100%, but we're seeing this progress kind of happen kind of fast. Are they going to put people out of business or are they going to just augment how well software developers can work? We'll see pretty soon. What I'm saying is don't expect a complete flop. I guarantee you it's not. We've seen credible people posting their results with DEVIN. It obviously does some cool stuff. We've also seen it do some not so smart stuff, right? So also don't expect this where it just takes over the whole world overnight. It's somewhere here and we're going to see exactly where it is as it gets rolled out. So here, Andrew Gao, he's saying my first task I asked for, so this is, I think he's talking about DEVIN 2.0 or maybe it's either the original or the new and improved version. Actually, he's saying this is March 12th, so I think this is the original. So he's saying he asked it to create a website where you play chess against a large language model. You make a move, the moves communicate to GPT-4, GPT-4 replies, etc. Right? So here was the prompt given to DEVIN. DEVIN starts working. And DEVIN, if you're not aware, so it has like 4 windows. It's got like its to-do list where it's breaking the tasks into subcategories. It's got a browser, a developing environment, and a way to chat back and forth with you, the user. And it kind of works on its own time, right? So it kind of goes off and it does stuff. And it might run for a while, right? So it's not like immediate response. It can do long horizon tasks. And so it looks like DEVIN goes through tons of stuff to figure out how to build this thing. It's asking for API keys, it looks like. And then, it's currently trying to debug something with the chessboard not rendering. But in the meantime, it asked it for, this other task, which is interesting, right? So you can have multiple sort of asynchronous tasks running. Also, he's asking to create a map of Antarctica sea temperatures in the last 50 years. It looks like it opens up web pages that it needs to find the information that it needs. So Andrew had to specify to make the hot temperatures blue and cold temperatures red, which is unintuitive, right? So giving it a kind of a weird prompt, not something that's expected. And DEVIN notes the color preference, saying, oh, wow, deployed to Netlify automatically, a live app. And now the first version is fully functional, but it has a bug, which is to be expected. Now let's see if DEVIN can fix it. But in conclusion, it got stuck on the chess thing, but it worked for Antarctica data visualization, even deployed it. Here's the kind of live app that you can go and check out. It nailed the prompt to create a fully functional Chrome extension that turns a GitHub repo into a Claude prompt. So let me know in the comments what you think of what DEVIN could do, because to me, it almost seems like what is it called? A Rorschach test, right? We're all kind of looking at the same thing and we're all seeing just drastically different results, different things. Because yeah, again, some people are like, oh, it's horrible, it's useless, right? It's zero. This will have no effect. Some people are like, oh, put everybody out of a job. But I feel like those two extremes are not reasonable, right? I mean, it's obviously somewhere in the center. It's doing cool stuff. It's doing stuff we would think is impossible like 5 years ago. And it still kind of sucks at some of it and can't quite figure out how to get around certain issues. But this thing isn't released to the public yet, right? We're judging this thing by, right, it's like pre-release capabilities of this brand new never before seen technology. I don't know, call me crazy, but I think this is going to have a big impact. Take a look at the founders. If you look at who the founders are, I mean, they're pretty like insanely impressive people. Take a look at the backers. Take a look at the investors. They're people who, let's say, tend not to lose a lot. They tend to invest in unicorns and hit it out of the park. So I don't know. I have no idea what's going to happen, but I would not be betting against DEVIN. And finally, I'll leave you off with this, yet another wearable device. And yes, I know we're all kind of maybe hesitant to get too excited about these wearable devices. This one looks weird, but fear not. I was concerned too. This orange piece in the center, I think that's just like a placeholder to make sure that it's, for shipping purposes. This does get removed. This is not what your face is going to look like when you wear them. I'm putting it towards the end because I know some people don't like me showcasing products. They think I'm getting paid to showcase this. I'm not taking any payments. It is interesting to see what's coming. A lot of these things will be flops. A lot of them won't be good, but some of them will be. Some of them will stick and become part of our everyday lives. And I personally always wanted something that could whisper comebacks in your ear. If you remember that Seinfeld episode where somebody insults George Costanza and later he's driving down the road and he comes back. He comes up with the perfect comeback. And so he recreates the scenario days later just so he can get up and say, well, the jerk store called and they're running out of you. And it was supposed to be the perfect comeback. It wasn't, but my point still stands. Imagine a life where if somebody says something that's annoying or insulting, immediately your AI assistant pops into your ear. I believe these are little microphones here on the side. These microphones, I'm not sure, those might be bone conduction microphones. So they transmit the vibrations, right? So your AI assistant whispers the perfect comeback in your ear and you just immediately recite it. I don't know. I would pay for that. Seems useful. Make sure you're subscribed to this channel. We're rolling out something really cool right now. So you don't want to miss it. Like for real, you don't want to miss it. I'll leave you off with this quick video from Frame, the open source AI glasses for developers, hackers, and superheroes. My name is Wes Roth, and thank you for watching.
Hi, I'm Bob Eck, co-founder of Brilliant Labs. And today I want to share with you a device that is as simple as it is capable. This is Frame. Frame sits at the intersection of artificial intelligence and augmented reality. It is designed to be open source, light, and affordable. And we believe this is important as we enter a new era of embodied AI. Powering Frame is Noah. Noah is our fun little AI assistant in the cloud, and its job is to orchestrate across potentially infinite number of AI models. And new models can always be added to its library, either by us or by an intrepid developer. But let's take Noah for a spin. Hey, Noah, you ready to show people what you're capable of?
Absolutely, let's do it.
Noah can see what I see. Take a look at what I'm wearing. Am I dressed appropriately for the weather?
A navy blue hooded sweatshirt should be suitable for the partly cloudy conditions with a current temperature of 72 Fahrenheit.
Now let's take this one step further. Find me a matching beanie and tell me where I can buy it and how much it's going to cost.
Yes, it's in. You can find a navy blue beanie at Target, Macy's, San Francisco. Prices range from $7.99 to $65 depending on the brand and style.
Cool. Now let's make this actionable for me. Choose the closest location and tell me the address so I can walk there.
The closest location is San Francisco, located at 505 Divisadero Street.
Great. Now, Noah can also generate images, and we thought this would be super fun because generative AI is new for all of us, especially when it comes to AI being embodied and seeing what we see in the world around us. So let's try that out. I'll just double tap on the side here. Show me in that navy blue beanie as a springtime superhero. Awesome. Frame is exiting the factories starting this week and heading toward fulfillment customs in the weeks that follow.